Well, my voice cracked. Hi. Hi. Hello. It's me, Scott. And I'm in Pittsburgh still. And that's fine. And I'm doing okay. And I hope you're all doing well. I hope everybody's having productive, safe day. Let's go safe first, then peaceful, and then productive can be third on the list. As for myself, well, lots of things going on, but tomorrow's the first like real residency stream that people might actually watch. So that is a thing to consider. Also things to consider are like, well, we'll talk more about this at length, but I've got 8 weeks to work on this residency project, which is pretty aggressive to begin with, but then of course the world is in a crazy state. So we will just have to figure out how that really works, like how it all really works, and that's okay. Other projects, I think I've got those figured out. Health things, working on figuring them out. It's okay. Lurking. Draclin, how's it going? Draclin's lurking. So, one thing though that I'm realizing that I need to work on is indecision, because I'm bad at that. I sometimes get paralyzed with indecision on what to work on. And the worst part about it, there's 2 things that are terrible about it for me. One is, there's that thing that not making a choice is a choice. And so I've had that burn me in the past many times. But I also have this problem where I can like have 2 options for something and get suspended beneath between the 2 of them to where I just cannot decide what to do. Like I'm in like this stasis where I'm equally pulled towards both. And it's indecision. You might call it analysis paralysis or that kind of like indecision paralysis. But there's that version where there's sort of 2 options and I just am like trapped between the 2. Or maybe the one that's more common is where there's just infinite possibilities of what to work on and how to work on it, what to do and how it should look and on and on and on. And man, it gets difficult. And I want to work on that. I've been reading about it a little bit, trying to figure out where my indecision comes from. What's the root of it? I think a lot of it is kind of like fear of failure sorts of things and perfectionism and all that kind of stuff. So anyway, it's time to make some decisions, I think. But also I don't know what to do. So we can start with kind of talking about where we are and where we're going and what we want to do next. Like what are the next steps for this? Because this is sometimes a tricky thing with the project. And I thought maybe I would just think through it on stream, because why not? Here's yet another Norwegian wallpaper. It's very nice. Let's get this thing up. So here's the like general to-do we had, and we did some of these things, and these aren't very important. But I want to think about like some very broad categories of what our next steps could be, because this is when you're just like feeling something out and prototyping something. I just dragged the wrong thing. Don't do that. I just did something very silly. Okay. Sorry, I'm messing with OBS. When you're working on a prototype of something, this thing barely exists. It's barely functional. It barely exists. It kind of gets the idea across. So I would maybe say that at this point, we're at the proof of concept phase. Like roughly, like barely at that phase where we can say like, okay, there's something to this. This idea of the shared motion control. We have very roughly proven that concept that we can do it. And now we have to decide what's next. So maybe first we like take an inventory of what we have. So these are the pieces of our proof of concept so far. So we have a mobile client that sends orientation and motion data. And that works. And it doesn't work great. It doesn't work super well. It doesn't look amazing, but it's like baseline functional. Like yes, on these devices we can get this motion data and we can send it out into the world. So that exists. We have a Node.js server for routing that traffic. So we have the very basis. I mean, it's tiny. This is our server right here. It's got a little more to it because we added WebSockets, but it's still quite tiny. So that exists. right now. What is in our notes file? Oh yeah, with some other, maybe we'll move this from to do to notes. So proof of concept thus far, let's just make this big. Why not? That exists. We have several viewing options, several visualization experiments. First, we have the rough p5.js queue visualizer. And that was the first thing we started with. So basically we have a thing that's sending data, a thing that's routing data, and then we have a couple ways to look at that data. So we have the p5.js queue visualizer, which really was just to get things started. Like, can we do this? Then we moved on to the Unity so then we have the Unity editor visualizer, where we can view those cubes in Unity. We added some stringies to them, like some very rough visuals, still extremely rough, but it works. Unity can talk to our server over WebSockets, even though everything else is Socket.io. So really this routes traffic via Socket.io and WebSockets. And it's a little weird to do both, but there's things I like about WebSockets. Well, there's things I like about Socket.io that make life a little easier, but Unity, for direct connection from Unity, WebSockets is definitely easier. And maybe we would flatten that in the future, possibly. So we have that. Then we also have the Unity WebGL version. So, okay, let's see. How about a Unity Cube visualizer? And then we have the editor visualizer with WebSockets. And the WebGL version with Socket.io. And that was, that took some work. We had to figure out this thing that I'd never done before with a native JavaScript plugin. And the compilation times on WebGL build times are a bit slow, which is not great. Why are you a different color? Interesting. If I keep going, will it keep changing colors? What? Okay. Weird syntax highlighting issues. Okay, so yeah, that took some work. So we got to this point, and now we're at this point. We're at this kind of next steps point of what do we actually want to do now? What would be useful? What would be interesting? What would advance the project as a whole? Like, we have some options on this, and I don't know the answer right now. And I was hoping to weigh them on stream, and we'll just see what we come up with, and then maybe move on to that thing. So when you've got a project like this, we have a rough proof of concept. So we have a few things that are kind of obvious. So one of them is polish the existing elements, let's say. So there's lots of things we could do to polish this up. We could clean up what the mobile experience looks like. Like that could look nicer. Like, refine mobile experience. Is it worth doing that now? I kind of don't think so, but that's an option. So we could refine the mobile experience. We could make the server more robust. And that is something we would need to do in the long run, probably, to figure out how to make things a little more robust. Or we could refine the visualization, and that could be work on, you know, we could work on the motion tracking. So we kind of want to advance the motion tracking. How could we make the motion tracking a little better? Or we could work on the, so work to advance the visuals and make it look nicer. So these are these are all options, and none of these are invalid, but there is a thing with prototypes like this where I don't think it's good to, when you've got a bunch of rough stuff, to pick one little piece and say, well, let's refine this all the way. Like, I don't think it would be smart at this point to spend hours and hours and days making the server super robust, because we don't even know what the experience is. And the mobile experience right now is just like kind of a dumb terminal, and it does the job that it needs to do. And so I don't know that we'd really gain much from that. Now, we could work, there's a case to be made for working on advancing the motion tracking fidelity, let's say. Things we could do to like lerp to smooth it out, or to, like we talked about, disregarding the rotation from the acceleration, so the acceleration is always true. So that could make it kind of a lazy follow. So if we did have a slow or chunky frame rate, let's see. One thing we could do here is devise a more compact data packet, because ours is pretty big and lazy right now. We could also work to, I just knew what this is and I lost it. What else was I gonna say we could do on the server? What was I about to say? I don't know, hopefully it comes back to me. Okay, motion tracking fidelity. We can alert to new positions. We could also remove data from, so in other words, right now, up is always relative to where the front of the phone is. And if I'm rotating the phone and moving up and down, it's changing what up is. But I would kind of want up to always be up, regardless of the orientation, and that would require some math. So those are things that could make that tracking experience a little better. Man, I really did have one more thing for the server. How could we make the server? So we said we would lerp to new positions, even if slow. Oh yeah, it was devise a more compact packet, and I'm pretty sure there's a way, I think we did this for some of our heat stuff, to send packets at a lower priority, to kind of say, because with this kind of data, you don't care. No one packet is essential. What's really important is a consistent stream of data, not that every packet gets there. And what you really don't want is like a traffic jam. You want to just spew out data and for the other end to process it as fast as possible. And if a packet gets lost, whatever, it's fine. You don't worry about it. You want to say, okay, I missed that one. No big deal. There's another one on the way. Because if there's a traffic jam, we can end up with this stuttering and kind of starts and stops. And we're going to be lerping to new positions anyway. So it really doesn't matter that much. And then work to advance the visuals. And that kind of is secondary visual effects, particles, etc. And then sculpture building, if that's still an idea we like. Like building sculptures or building artifacts from it. So these are the pieces. These are the pieces of what we have, and these are ways we could polish those. Now, these are getting a little bit This one is, so let's actually make a split here, because that's actually like a new thing. So these are like our refinement options. These are the things we could choose to do right now to advance this proof of concept. However, we also have the option to do new work. And that's where this decision can be difficult, because it's like, okay, we built out all these pieces, our three major pieces. We have a client, we have a server, and we have a visualization at the end of that. And we have the option to refine those pieces. So now we want to decide, well, we could decide like, well, maybe there's actually something new that we want to do here. So some of the new things could be experiment with the session data storage. Meaning, if we wanted, so one of our ideas is that as you do your dance and you draw and you create something, that something is stored, and it's either stored as the final attributes of that object. So store final attributes of created object, or it's store all progress to create that object. Whatever that is. So I hope that that distinction's clear, because they're pretty different. It'd be like if, I just bumped the desk majorly. It would be the difference between, I wonder if the music is too loud. I hope it's not too loud. Life is Yours isn't around as my official audio reviewer. Say I'm drawing a picture. There's two ways that I could store that in a database. I could either store the final pixels, like the final result of that picture, and that's pretty easy. Or I could store every brush stroke to recreate that picture, and then at any time I want, I could draw the picture again in real time. So there's advantages and disadvantages to that. Like this, it's certainly easier and more compact and more reliable in some ways to just store the final object. But you lose, since this is potentially a gestural movement-based creative tool, you lose all that. You lose all of the movement. So from that perspective, I think it's actually nice to store all of your progress, but it's way more complicated because there's way more data, and it's data that's over time. So you have to store some kind of stream of data. Say you have MongoDB and it's some kind of document. That document needs to have all the instructions that describe how I moved and what I did, and if I push the screen buttons on the screen or whatever happened there. So it's probably orders of magnitude more data than it would be to just store the thing. Maybe, because in some cases the final artifact, say it's an image and it's a bitmap image, and I have to store data for every pixel. You could imagine that taking quite a bit of information. If it's 32 bits per pixel and it's a million pixels or whatever it turns out to be, then that is potentially a lot of data. But it's probably less than the whole movement thing. So this is kind of a whole new field of inquiry. It builds on some of these features that we have, but it's kind of a whole new thing. So that would be the data storage aspect. Like as that data comes in, maybe on the server, it's deciding to store some of it. There's also the or reconstitute the image from the stored data. So those would be entirely new. That's entirely new work. And that's like server database work for the most part. And while I could see that work being valuable, it feels a little bit premature. I think it's good to have, like, to consider it and have it on the list, but it feels a little premature because we don't know what that stuff is yet. I mean, we don't exactly know what the data is. We could assume now, like, okay, maybe it's our data packets that we're sending. These packets, if we just stored these packets and then we're able to replay. And there's something cool about that, for sure. Something interesting about that. But I don't think we know, I don't feel like we really know well enough yet what that thing is. So then we have this other option that's like explore visual design options. And that could be like work on a mood board and do motion and visual testing. So this is like these are very different trajectories we could take. This sends us deeper into the data realm, kind of fully removed from the front end, and just says what's the really deep back end stuff that's going on to make this thing work. Which doesn't sound quite right, because again, we don't really know what this thing is. Alternatively, we have this explore visual design options, and it's way on the front end. It's so far removed, it's not even like dealing with code or anything. It's just purely doing visual explorations. I kind of want to save this for one of the residency streams, I think. Just as like an example of how to do that thing, and it's not technical. You know, it's not as technical as a lot of this other stuff. So it might be just an interesting thing to talk about. Like, what does it look like to put together mood boards and do those kinds of visual tests and experiments? So that's definitely possible. You know, we also have like concept development work to do. Themes and goals. Of the artwork, what the interaction is like. Like these are ideas. This is all sort of ideation work, whereas this is very technical work. We've had a little bit of a mixture right now. I think that's also something I would like to do on stream. There's also like generating physical artifacts. I don't think that's such a separate idea. I don't think we're going to do it, but it's a something. It's an idea that maybe once you make a thing here, there's some option to have it ordered from Shapeways or something like that, and you can get a physical version of your thing. Which there's something interesting to that, but it's also very much a secondary piece. And because everything is so nebulous and the timeline is relatively short, that feels like I don't want to think about it right now. Like once we're in this realm and we're thinking about what it takes to store and reconstitute something, we could definitely look at the idea of, well, what if we reconstituted it as G-code and then you could 3D print it. So there's something to that. So, okay, that's all off the top of my head. There's, of course, tons of other work to do, but just purely off the top of my head, those are things that's kind of our vague to-do list. You know, from this you'd boil it down to individual actionable items. And then there's like residency work, stream planning, for example. I have a stream tomorrow that I could do some planning on. Maybe I'll do that later tonight, though. I'm going to spend like half an hour on stream planning because I tend to like to do those sort of things off the cuff a little bit. Okay. So, looking at all of these things, and I'll add one more thing to this. So this, I think, was kind of a brain dump thing, which I think is useful to do at all stages of a project. Just get things out of your head on paper so you can sort of shuffle them around. So I feel like I mostly have the stuff that's bouncing out around my head about this project on paper in front of me. I mean, there really is this other option. Because this is one idea. This is one idea of using the phone, and maybe there's other ways. There's maybe different ways we want to do it on the phone. Like maybe we track your face and you dance with your face instead of waving your phone around. And then you only need one screen instead of two screens. There's also the ideas of what happens in the museum and what those sensors are, and do we get one of those Intel cameras, and on and on. Like that's kind of its own thing. That's a whole other thing, which, I think we need to. So there's another possibility here where we look at all the work we've done, we look what the work we could do, and we decide, like, you know what, this particular proof of concept is actually done. That this phone version is done. I think that's not true. I think I actually would want to refine it a little bit so that it was a little more, we could put a little more of put a bow on it and be like, this is a complete thought. And I don't think it would take too much work there. That would primarily take some more visuals work. So that is not a bad idea, actually. If we wanted to, say later in the week, look at what do we need to do to make this a complete thought? Like, this is now a prototype, not just a proof of concept. It is an execution of this idea or it's still a proof of concept, but it's a further development. And then, like next week, we just say like, okay, now we try the new version. So that is something to consider for sure. Okay, I'm going to get a drink of water, and then we're going to come back, and I'm going to work on not being so indecisive, and we're maybe going to make some kind of decision. So let's see how that goes. Okay, I'm going to add one more thing to this decision-making process. And really, like, my working process is another consideration here is, for me, and I don't know that this is true for everybody, but I'm not the only one. I've definitely talked to other people who have this issue. There's a cost to shifting modes in work. And what I mean by that is, like, there's a mental cost, a time cost. How's it going, Life is Yours? For me to shift to a completely different mode of thought. So just looking at the to-do list we have here, we have, well, like we could just break it down. We have server-side JavaScript development. We have client-side JavaScript development. We have Unity networking development. We have Unity front-end design and development. We have visual design and ideation and concept work. And those for me are different mental modes. Like it's not easy for me, for example, to spend time working in a visual design mode, like in visual design software and visual design, and just immediately switch to software development. It's also not easy for me to just switch technologies on a dime. Like there's a cost to that. A cost in terms of like time spent and in productivity. I think I'm less productive if I'm trying to constantly switch those modes. I think I'm less effective. And so that's an important thing to consider. And also, so it's not good to constantly be changing modes, for me. The inverse is also true. It's also not good for me to get too hyper-specific or hyper-focused on one mode for too long, or I'll feel some fatigue for that mode, and then maybe that starts costing the rest of the project a little bit. So it's another thing I'm kind of learning about my working process is the difficulties of that. And in some ways, it's like, I broadly, for the way I bill projects and in the way I think about my work, usually is not based on hours. It's based on days and then sometimes half days. So ideally, I'm not doing different kinds of work. I'm not switching to totally different kinds of work more than every half day. That's the ideal. And that's not really the truth, and it often happens more frequently than that. But I think maybe for me personally, the ideal is kind of like, okay, Monday morning up to noon, I will do this kind of work, whatever XYZ kind of work is. So today for me, for example, that work was mainly administrative work, which is work that's not even listed here. That's work that's like sending emails and working on contracts and dealing with finances and whatever. It's like the like part of being a freelancer and being your own business and all of that kind of stuff that is in many ways my least favorite part, but it's also often the part that's just like, you just do it. And frequently there's not a ton of questions here. There are questions in coming up with contracts and stuff like that for sure, but the admin work is not the same kind of mental exertion as these other works. Usually, it can be, like coming up with contracts really can be stressful, but it's at any rate, let's say that admin work is different than design and concept work, and that is different than technical and software development and hardware development work. So, given all of these things, and the fact that I've talked for 30 minutes about making a decision and I've yet to make a decision, there's one more thing that I will add to this, and that is something I do believe in, and sometimes it's good and sometimes it's bad, but when you just don't know what to do, to follow the gravity of your own interest. And that's something I try to have some faith in, is like, once I have all this stuff down in front of me and I've got this big list and I just look at this list, and yeah, there's some logical part of me that can be like, this is smarter than this and that is smarter than that. So I can look at this list and I could maybe prioritize it the way, whatever, I don't know, is that a chief operations officer? I don't even know whose job that is, to look at this list and be like, these are the priorities. Or, like that's kind of a project manager, a producer kind of project. I could maybe do that, but I don't want to. I'm going to do this other thing of just like, I'm going to follow the gravity of what is interesting to me, even if it's not the number one priority, because knowing myself, I know that because I'm interested in something, I will be a more effective worker on it. So even if I, for example, said, I don't know, if I said, for example, remove orientation data from acceleration, I don't think that's most important, but let's say that was the most important. I don't really want to do that right now. It sounds kind of annoying. It doesn't sound that hard, but it sounds a little annoying. Like these two things are kind of mathy and we could do them, but like, because I'm not really into it, I might be a little cranky and I just don't think I'll work as effectively. For some reason, and this is send packets, no, sorry, this one, devise a more compact data packet. So I could probably make a case to you that that's the least important thing on this entire list. Like, I could maybe look at that and be like, yeah, that's not important. That is optimization that we're not even close to. So I shouldn't even be thinking about it. However, for whatever reason, that's the thing to me that just feels a little bit interesting right now. It just seems a little interesting to devise this, because sometimes that's the kind of mood I am. Sometimes I'm in a kind of mood that's like, I don't want to work on these new things. I don't want to work on these polishes. I want to work on efficiency. And so even though that's not the number one priority, I think that's the thing I want to play with a little bit today. Devise a more compact data packet. So we sort of have, let's just do it for this stream. We'll make a decision, and that's our decision. We may not do it for the whole stream, but that's the decision we're going to make right now. So we have two very high-level options here. And those two options are, I think ideally in either case, these are binary packets. So it's a custom binary packet where we come up with some scheme of our own to pack whatever number of bits we think is a good number of bits into a packet, and then we send that packet. That is almost certainly the most efficient, like, because then I can literally say, like, yeah, this packet is whatever it is, 10 bytes, whatever it is. Let's say it's 8 bytes, so it's 64 bits, and we put exactly what we want in those 64 bits, and then we unpack those bits at the other end, and it's about as tiny as something could be. That's one option. The other option is no. Yeah. Right? IE, is that an example? One's an example and one's further explanation. IE is to restate something. EG is to give an example. Yeah, egg example. So we want EG. Google Proto Buff. So I've used Proto Buff some years ago. Looks like it's still in development, which is cool. So the plus side of this is that Google has done the work. They've come up with this clever scheme to do all this like packing and unpacking and efficient ways to add new things and deprecate old things and all that from these packets. Like you can build this living packet that evolves over time. And there's definitely cases in which that's pretty clever. And it packs pretty tight. It's not as tight as I could do it myself because there's some overhead. Like they have some overhead to say what's what. It's not a lot of overhead, but it's a little bit. And since we will be constantly spewing packets, you might say like, maybe we don't want to sacrifice for that overhead. One of the other advantages of this is that you can have different versions of things. So different software out there could be using it and you can still use the old version and it will be okay. Like in our case, we don't really gain from that because like we're going to be doing the work. Like I'm not going to update the server without updating the clients, you know, like that the current version will always be the version. We don't really need the ability to add new fields or deprecate or any of those things. Not really. So let's look at our packet as it exists right now. Our packet right now is ridiculous. It's like probably many times larger than it needs to be because we're just sending a big old blob of text. We're sending whatever is in sensor data, right? And sensor data we'll end up with all these fields. Well, that won't be very useful. We did it on the server. Yeah, so if we get data on the server, be right back. I just punched myself in the face with my headphones. They're out to get me because I keep like contorting them and bending. Okay, so let's just log one of these packets. What's this thing called? Mobile, answer, mobile, send, allow. Okay, so this is one packet right now. Really this, because we're just sending a blob of JSON. And that is not so efficient at all. So what does it look like? This packet right now is, you want to tell me the number of bytes? I want it in like, no, I just want to like paste. Shouldn't that tell me that? I guess I could save it and look at the file. This thing. That's UTF-8. And that's more bytes, right? But I guess I have no UTF-8 here. So this is almost 300 bytes to send this data. And that's pretty crazy. Like this timestamp that we're spending 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. We're spending 24 bytes on that timestamp when I'm pretty sure it's a 32-bit number. So that's 4 bytes. Now, maybe that's dangerous because there will be a day when that will overflow in 18 years, but I'm not sure if I'm worried about that right now. It'd be pretty funny. That's the year 2838 problem, which is kind of more of a real problem than the Y2K problem. Yeah, assigned 32-bit integer. Wait, why is it signed? What if it's unsigned? Okay, so using unsigned 32-bit extends to 2106. So that's actually fine. I could use, so in other words, I can use 4 bytes and be okay for a long time. Till February of 2106. I'm gonna say I'll be 126 years old. So yeah, right. Add a counter to count the times I loop through. I mean, I could just stick it in a 64-bit number and then it goes to like, yeah, 292 billion years. But I don't think I need to. Yeah, that's 20 times greater than the estimated age of the universe. Isn't that amazing? The change of going from 32 to 64-bit, like pretty staggering. Where 1 gets you like 136 years. 32-bit can go about 136 years. and 64-bit can go this many billions of years. That's pretty crazy. But as long as it's not signed, it seemed like we're fine. Okay, so that would be something like... So our timestamp should be something like 4 bits. No, 4 bytes. Is that is capital B byte? What is the abbreviation? Yeah, capital B is byte, right? Yeah. So we want 4 bytes, which is 32 bits. Because another thing to consider, we need to consider this for 2 reasons. One, because we're sending this data a lot. We're sending this data something like 30 times per second. Maybe we throttle it a little more like that, more than that, but something like 30 times a second. And that adds up very quickly if you have a lot of users and the throughput. So for the individual user, sending data is a concern. For whoever's receiving that data is a concern, because if you have 1,000 users, that's a whole lot of data coming in all at once. And then also, if we want to do the thing back to our list of things to consider, where is that thing? If we want to do the idea where we reconstitute this, we need to store all this data in a database forever. And that costs money, depending on how big the data is. So definitely something to consider. So we want this packet tight. And that's why I think this is not totally, even though it is an optimization, it is a worthwhile thing. Even if it's not the most, the smartest thing to work on at this moment, it is something we do care about. We really want a small time. And we could actually lower this dramatically by abbreviating these. I mean, that's where much of our cost is, really, is in just the text to write these long words. So if this was T, I, M, A, X, Y, Z, O, A, G, B, it would help us shrink this quite a bit. But there'd still be colons, and there'd still be quotes potentially. There'd certainly be commas. Like, it still would be inefficient. Even if we pared down to that, we could still probably cut it half again by going down to this. Again, right now our timestamp is only costing us 4 characters. So our whole timestamp fits here instead of what was in this whole line. So this whole thing was, 25? And now we're down to 4. So it's like a 1/6. So timestamp could get that tiny. The ID, I don't know. Because this is huge. Like, this might be 256. Because each of these is counting up to 250. Man, I don't know. This is a big number. This really is kind of using... I mean, this is something like 20 bytes. I mean, because there's 20 here, and if we're using anything that can go in one of these bytes... I mean, it's obviously 20, but I mean, like, maybe it could be packed with the same data in something smaller, but... But I don't know if the comma is always there. I'm not entirely sure. So that's bigger than we want. We don't want collisions, but we don't... yeah, this. So Jacqueline found that GUIDs, like. So we can do 2 billion. No, unsigned. Well, it'll just be double that-ish, right? Why are you highlighting things? What? It's like 4 billion. Not very likely that there would be a collision, but possible. I mean, there'd be a 1 in 4 billion chance that you got the same number as somebody else. Jacqueline found that like list of GUIDs. You're real long, man. That's also for like a partition table, I think. I'm never gonna find that, am I? A list of awesome things related to goods. Cool. Very nice. No, don't put GUIDs in URLs. Why? So? It's like a Usenet post from 40 years ago. Only has that feel. Not that old. Well, that's a concern for another project. I don't actually care that much. I want very short GUIDs. Ooh, some people say GUIDs. I always said GUID. I don't know. I thought this was actually useful, but it seems to not be useful. Very long. This GUID is not hot. Sorry. Okay, this is. I thought this was actually a useful list of things, but it's not. It's not. I want 4-byte GUIDs. Is that unreasonable? Is that just silly? 32-bit GUID. Maybe that's not enough. So one thing I could consider we know, yeah, I'm about to say this. Maybe I believe it, maybe I don't. Like we only really care in a narrow time that they're unique users. We don't care if they're from all time because they would have different timestamp windows. So even if you had a number yesterday and you had some kind of time window, and I had a number today and I had some kind of time window, maybe that's fine because the time window is what matters. We need to be unique for the window of time. So what I was just considering is if the ID is time plus some nonsense, like it could also be that the server tells you. That when you connect to the server tells you who you are, and then there can just be one source of truth, and it can increment forever, and that's easy. I do want to know about that ID though. Like, I want to know what it's made of, What are you made of, friend? It's Teacher Appreciation Week. What is it, though? I don't want to know how to get it. I want to know what it is. Generate ID. Oh. Interesting. So I could overwrite. I'm not really seeing what I want here, though. This says it comes from the client. Wait, didn't I just go to client? Client. I don't know, man. I do need another time. Okay, well. Let's just say for now that it's 4 bytes. Let's just say that. I don't know if it's true, but let's just say it. Then we have motion. So that's, and under that's acceleration. We don't actually store these things if we don't want to. We can just say that the layout of the data tells us where they are. So in other words, I don't need a label timestamp. I just know the first 4 bytes are the timestamp. So then we have acceleration, then we have X. So X is a float. So how precise, is that half precision? Still a lot of precision. At the 65, 535. So you have I want a chart that's like, no, it's not the chart I want. None of these look like charts that I want. Like just a chart of powers of 2. Okay, so that would be, how is that possible though? How come I can count to 65, 535 and still have, oh, I can't because some amount, something is reserved to say if there's a decimal, right? But that says there's only five bits for the exponent. I just don't understand how it works. So if all these bits are 1, because that would just be 4 bits. Oh, does this mean there is or isn't a decimal there? No. I just don't understand how this encoding works. I guess I could actually learn, but all that said, 16 bits is probably adequate. That's 2 bytes each for each of these. Not you. And then similarly, we'd have orientation, and we'd have alpha, beta, gamma. And I believe all of these could also could fit into 2 bytes. So right now, if this is what we went with, our whole packet would be 20 bytes. And if we did that 30 times a second, that's 600 bytes a second. And that's 3,600 bytes a minute. So 3 kilobytes per minute if you wanted to track all this data and store it. So if somebody used this for 10 minutes, the whole thing could be stored in 36 kilobytes, which is pretty tight. I mean, that's incredibly tight packing. That's probably not, we wouldn't do that. It would take more space than that. We would, the storage we'd be a little sloppier with, as far as like, just to make our lives a little easier, we'd store it as a document in Mongo probably, and maybe there's compression and stuff that could help us there, but I kind of want to try this. It's because I haven't done anything like this for a long time. We basically want to create all of these numbers at the sizes we've just described. And then we want to pack them all together into 20 bytes. So going back to where was our thing? We lost it probably. This thing. Whatever we were basically 300. Yeah, like 300 bytes. And then we would be down to, basically just this. So more than an order of magnitude improvement. And I think it's almost always true, I think, that if you can make an improvement that is an order of magnitude improvement, you've done good work. Like sometimes doubling a thing is not as important as it seems, but man, if something is 10 times better, that's probably better. So, how do we do this? I don't know that there's any tools to do this. If there's like a half, there's doubles. Or there's like the big int. Yeah, we don't want double precision. If we wanted, doubles are 32. So like, if we wanted to create our own 16-bit number, that's all bitwise stuff that I just, we're not even to the bitwise part yet, right? Like we just want to, oh, our floats, these can be negative. Shoot. These have to be signed 16-bit numbers. Well, but we already were looking at signed. High precision floating point for JavaScript. I don't want to add a whole thing. I mean, okay, I will say, not having to deal with this would be one of the perks of using Protobuf, because this is stuff I'm just out of practice with. Ooh. Well, these are not totally trivial. But is this the thing I can have? Oh, that's UN69. Let's float 32. Mm-hmm. Well, this is not... Wait, how did that happen? Where did all the... Why are there TikTok people on Quasi's stream? Quasi, is that how you say it? Q-A-Z-I? That's Quasi, right? Okay. Maybe I don't want to deal with this right now. I feel like this would be much more straightforward in another language, but not in JavaScript. Oh. I think you told me about that. So he's a TikTok hero. TikTok star. Basically. You know what? This makes me feel like I don't want to deal with this. I mean, we could certainly like cut and paste some code. Sure, we could use some existing library. I see, that's where the exponent goes. It's cool. This is cool, but I just don't know if I want to deal with it. Because we could just do protobuf, probably. What are our types? Well-known types. Float value and a double value, but is a float value 32 bits? I mean, that's all a lot more. Average? What am I averaging? Why does nobody care about half precision? Guess it, I mean, do it in shaders all the time, but. Also, extremely possible that I just don't understand the problem enough. Maybe there's like some reason. Some reason that things are like this and that nobody cares about. There's some other type that we cared about. What's a value? Is it a string? Big old doubles. I don't see any 16-bit. I could do a bytes value, I guess, and stick my 2 bytes. But if I'm doing that, then why? Oh, is it like computationally significant to do these conversions? I would kind of guess not, compared to the overhead of sending them. Like, so like if I had to, you know, if I had to turn into bytes anyway, I lost my place. Where am I? Well-known types. Stop it. Cardinality. Oh. Yeah. Because something to consider is whatever we do, whatever insane things we do to pack these bytes, we've got to unpack them potentially in a few places, potentially at least in JavaScript and in C#. So that's something to consider. Like, that's interesting. That seems real easy. Maybe. Or too short. That'd be easy to do on the Unity side. Oh, I see. Huh. 8-8 notation. You want to connect the dots? Like, as you click, they connect and sparkle around? Like the standard, you know, like the... these kind of things? We could do that. Just so I can have weird particles on my screen all the time. Should I do that instead of working on the thing I'm working on right now? Because I feel like I've worked on an hour and a half and I just frustrated myself. I'm learning some things about that things are more complicated than I thought. Give them lifetimes? Yeah, that'd be easy enough to do. You could do it all in processing or do it in Pixie or whatever. And then as they got close. I mean, it's essentially just this thing, right? Like, what do we do when we hit an edge on one of these? I can't remember. I think they just die and we spawn new ones. I can't remember. It's not very complicated code. C++. Oh, well, this would be in either JavaScript or, well, it'd be in JavaScript and C#. I just need an easy implementation. The 8.8 is kind of interesting. That means you've got 2 bits and you dedicate 8 bytes to the decimal and 8 bytes to the whole number portion. And that's maybe adequate for me. That may be all I need. Like, I would essentially the 2 bytes. Yeah, I think I could. What do they call it? What do people call this? Kind of like this idea. It does mean that on, you know, you can only count to 256 on one side, but maybe that's fine. I kind of like it. Gosh, 4-8. Well, this will get really weird because we'd be like using partial bytes. Which means we couldn't count very high. I mean, maybe I could do it in 4-4 and do it 1 byte. Is that crazy? Is that crazy? That might be crazy, but it might be cool. I don't think that would be that's not enough precision. Because we could only count to 16 on both sides. Maybe 4-8 would be adequate given the space we're operating in, but I don't think so. I think we need like 8-8 seems reasonable. Maybe. Still a lot of precision lost, for sure. But I don't think it matters. Like, do we really care about all this precision? I don't think so. But that said, it seems less efficient than that like actual whatever. That actual like float 16, this half precision seems like a smarter way, like you get more flexibility in it. Certainly. So what is this called? Updated 18 hours ago. Like a data view. Is that a thing that I want? I don't know, array buffer. Then I could set those. That seems not bad. So if I set interesting. So I make that array buffer, and then my data view lets me mess with it. But like, if I'm messing with, that sounds kind of cool. Set int 16. The float 32 and so all the stuff is here except for what I want, which is a float 16. So if I do this, it starts at an offset. Oh, I mean, this is like kind of exactly what I want. Because I could say set for these are easy. These are set int 32 from the offset. It's just that there's no float 16. But then on the, so what's going on over here? Can I do the exact same thing on the .NET side? No. This is different. Data view is a completely different thing here. So I just want like some bytes and a buffer. Is that like what I actually get on the... Set a byte. I mean, I guess it would be getting a uint 16 out of a... That gets a byte. I want more than one byte. Block copy. Interesting. Okay. I'm gonna pause all this because it has obviously turned out to be more complicated than I expected, mainly because the primitives I want are not super available, it turns out. Primitive, like the, I don't know if that's quite the right number, like the number primitives, like a 16-bit float, just isn't a thing in JavaScript. I could definitely just say, if all of these were just 4 bytes, it would not be that big of a deal. So what did we have to, like, what do we actually have here? We need float 32s. So that, I mean, we'd have int 32s and float 32s. But then that means all of these are instantly double. That becomes 4 bytes and those become 32. Or bits, not bytes. So suddenly we're at 48. Is that right? Wait. That's now 24. No, 32, sorry. 6, 4, 24, another 8. So now we're at, that would be 32 bytes, which is still close to, not quite as good. We haven't quite gained an order of magnitude there, but it's an improvement. And that would make life a little easier in the near term. And then to get those, we could just get everything in and out. It becomes pretty easy. And I think you can just send binary data if you want to, right? Yeah, you can send an array buffer. You can send the view. Would that be our data view? It can be a data view. Let's just try it. Let's just try that piece of it. We won't even do the Unity side. We'll just do the JavaScript side just to see what it's like. And we'll do it in a relatively inefficient way. I'm curious about it. And then we'll feel like we did something, and then maybe we will get distracted by Life is Yours, the champion of distracting, and do a change our stream content. So content. So what that would mean is we would want to do something like make a data view. Does that actually mess with it? So, okay, let's just try this. So what does that end up being? We had 8. I've lost myself. 8. Fields, 32 bytes. So if down here in mobile land, when we send that sensor data, wherever that is, say we did something like this. And that was 8. So if we had that, and then all these places that we just update that, so the question would be kind of like, do we bother? For now, let's just do it all at once. Let's do it all in the same place, just so we don't mess with any of the existing code that we have. So we need to say, we're gonna have 8 things here. So we're gonna be doing, this is the offset, and this is a value in the Indianness. I don't think we need that. I hope not. Okay, so let's do like, and these are the bytes, right? And the offset. What is that? That's the byte offset, not the bit offset. So we really only have so this is what's going to go into those fields. That's the timestamp. That's the ID XYZ and the alpha, beta, gamma, right? So into these spots, these are all going to be set float 32. And if we got that 16 implementation, we could try it out. But this and this is going to be sensor data dot is that right? Sensor data dot motion dot acceleration dot x. Yeah, XYZ for these. And this is sensor data dot orientation dot okay, so that sets all those. This was sensor data dot timestamp. And this should be a 32-bit int. Wait, this is all wrong. This is all wrong. This is 32 bytes. 32 bytes. Bytes, bytes, bytes. And this is 32. So this offset is 4. Oops. Right? Those are all going to be the offsets. How do you do that? And this is just going to be whatever. The ID's broken right now. Like we can just try to, whatever data goes in is not coming out properly. We know that, but we're going to just call that okay for the moment because I'm curious about this. So we have this. This gets the data for us. So if we how are we going to do this in a sane way? I don't know if you had to do anything special. Nope, we need to send it. So let's send a a different. We'll emit a totally different thing, and then over here, let's say when we get a sensor data. We get a sensor data binary. That's the binary blob we've just. I don't actually know this has come in as the buffer. I mean, maybe we should send the buffer just so we for sure. Is that what we called that? Sensor data buffer? Let's call it the sensor data buffer. Okay. And now over here, when we get that, we're gonna have a sensor data buffer, and we're gonna need to do we need a data view. And then let's try a timestamp equals sensor data view dot get int 32 0. And then down here, let's also sensor data timestamp and a timestamp. Okay, so now put it. Let's try to send something. What did I do wrong so I'm not seeing my binaries? Sensor data timestamps. Socket on sensor data binary. Did we not send that correctly? Sensor data binary. Okay. That still seems wrong. What did I do wrong? It would appear I am emitting a sensor data binary. Oh, we're not routing that. We need to also say sensor data binary. Let's not WebSocket broadcast it yet. Let's turn off this logging. Okay. Okay, we have a problem. Cool. What did I... That's a data view. That's the buffer we just got. And we said, is it mad that we didn't set the Indianness? Is that just not actually... I don't think we need to set the Indian mess. Is this more than a... Oh, because this has milliseconds, is that right? Right? I think. I forgot about that. Okay. So for example, 116, these are the milliseconds. So that is just rounding those off, so that's actually okay. Okay. So that is a 32-bit packet. Our ID is going to be real wrong. But let's try like orientation alpha. Well, let's quickly just get all this stuff. One. Alpha, beta, gamma, and then similar offsets. That's a 4. These should all be floats. Oops. Right? So let's try just the gamma. Which we shouldn't lose any precision here. I don't think. Oh, maybe we do. These actually look like they're higher precision. These are doubles, so we're going from 64 to 32 bits. We are losing some precision, but at like, I don't know even what that is. Tenths, hundreds, thousandths, millions, billionths. I think we can do without that. I think we can live without that precision and have it be okay. Okay, well that was a long route, but we did the thing. We haven't actually fully implemented it because now we would, to really do this, we would then need to do it on the Unity side. And that seems a little bit more annoying. But we now have a reasonable way to pack a bunch of binary data into a bunch of bytes, then send those bytes and feel okay about them arriving at their destination. We went from almost 300 bytes down to 32 bytes, which is pretty good, but I really would like those to be 16-bit floats. Kind of bums me out, but that's not a thing we can do. Do we have any other, is there any other, what were our data types of that? Oh. Because an unsigned int 16 is what we want. I mean, if we had it's 16 bits, so like, these are not what I want. Yeah, we'd have to do all the magic, right? So where was our friend? Our friend that wrote the thing. That was this friend. Kind of lame that that's not just there. Yeah, man. This guy, he knows. He wants it. Yeah, this person's doing the thing, converting to a... Well, it was in the agenda 3 years ago. Well, my dude here, Peta, she or he has done this thing. And it seems kind of cool. It would get the packet down from 32 back down to 20. Which, if we add more and more and more of these, that could be a real thing. Okay. Well, I'm starting to get work messages, so it's probably time to go back to work world. We figured this out. We got a binary packet. It's not as tiny as I would like it, but it's close to 10 times better than what we had before. So, and I have a better understanding of the landscape of exactly what's going on here. I think that at this moment, I like the idea of building my own packets because it's pretty simple. If we can just do this thing, like if we can just do this and use these with the data view, so far that seems really easy. If we need to do the Unity side of things, well, yeah, we do. We do need to do the Unity side of things before we really decide if that's a great idea. But it's less overhead and extra stuff than using protobuf, and probably a little bit tighter because they don't seem to support float 16 either. So, yeah. I'm into it. We did some stuff. Not the most productive day of all time, but we moved, excuse me, hopefully a little more forward than sideways. That's always the goal, right? I very frequently move laterally on projects. As long as I'm not moving backwards, I feel like I'm doing okay. So thanks for joining me. Life is yours. I'm going to take your suggestion. We need to do the, it's time to go to the store. You get yogurt. You got to get yogurt. Always get yogurt. I'm going to take your suggestion, and I think we should do that heat thing. But I think we're going to do it as one of the official residency streams. So starting tomorrow, and then on Thursday, we'll do like an official residency stream. And I think we'll just make it during the second one. We'll like make it during the Thursday one, because tomorrow I'm going to introduce myself, talk about projects. Then Thursday I'm going to talk about tools that I like to use. And I think that P5 will be one of the tools that I talk about. So yeah, let's do that. Okay, thanks for joining me, and I will talk to you so very soon. Have a lovely day and be safe.